Okay guys, today I'm gonna go over how to find the missing length without using the Pythagorean theorem, okay? So let's look at number one. Okay, in number one it says find the missing length, round your answer to the nearest tenth, okay? Meaning you only take one digit after the decimal, okay? So right here, notice it gives us an angle, 22 degrees. It gives us the adjacent side and also the opposite side, okay? Now, we can't use the Pythagorean theorem for this problem is because we don't have enough information, because we only have one side and not two. To use the Pythagorean theorem, you need to know two sides, not one. So this is why we learn trig, okay? So the sixth trig function that we learned yesterday was sine, cosine, tangent, cosecant, secant, and cotangent, right? So based on this picture right here, we need to use tangent. Why tangent? Because only tangent uses opposite and adjacent, okay? So this is how you would do the problem. So you're gonna go tangent 22 degrees equals to opposite, which is 13, over adjacent, which is x, okay? And then, so that's how you would set up the ratio. Now to solve for x, which is the missing length, we're going to put this over 1, and then we're going to cross multiplied, okay? So then we have x times tangent 22 degrees equals to 13. And then to get the x by itself, we divide both sides by tangent 22 degrees. That cancels out. So x approximately equals to 32.2. Okay, now you need to use a calculator for these problems. So on your calculator, you would press 13 and then the division symbol, and then find tangent on your calculator, tangent 22, and then enter it. Okay, you should get 32.2. And also make sure your mode, the calculator mode, is in degrees and not radian. Okay, if it's in radian, your answer will be all wrong. Okay, now moving on to the next problem. For this one, it gives you this angle right here, 64 degrees, and the size that it gives you is the hypotenuse and adjacent, okay? So you would ask yourself, okay, what trig function uses adjacent and hypotenuse? And that would be cosine. So you write cosine 64 degrees equals to, adjacent is 10 over x. Now I'm going to make it into fractions, and then we're going to cross multiplied, okay? Then we get x cosine 64 degrees equals to 10. And then we're going to divide both sides by cosine 64 degrees to get x by itself. Oopsie, cannot write today. Cosine 64 degrees. So that cancel. So the next part is calculator. So you would press 10, divide, and then cosine 64, and then entered. And then you would get the answers approximately 22.8. Okay? Okay, moving on to the next problem. Number 3. Same thing. We look at this angle right here, and according to that angle's perspective, we have adjacent, and then we have same thing, just like number 2, it's going to be cosines again. So we're going to go cosine 28 degrees equals to, adjacent would be x, and hypotenuse would be 15. We put this over 1, and then cross multiplied, okay? So 1 times x is x equals to 15 times cosine 28 degrees. Okay, the next part is just calculator. So you would press cosine 28 onto your calculator, and you would get 0.882948, and then times that with 15. Your answers come out approximately 13.2. Okay, that's number 3. Okay, in number 4, they give you 31 degrees, and opposite is 13. Hypotenuse is x, so that means we have to use this sine function. So sine 31 degrees equals to, opposite is 13 over x. Then we're going to put this over 1, and we're going to cross multiplied. So it's going to be x sine 31 degrees equal to 13. Then to get x by itself, we're going to divide both sides by sine 31 degrees. So x approximately 25.2. Okay.